All right, so now we're ready to take a look at a different example here, and you can see we're given gamma, A, and C. And the important thing to understand in a problem like this is that you really have a lack of options. You can't do anything but proceed with the law of sines here, and only in one way. So it's pretty clear that we have to go sine gamma over C equals sine of alpha over A. And by having that given information, now that's going to allow us to solve for alpha. So sine of 128.6 over 8.2 equals sine of alpha over 9.6. So that tells us that sine of alpha is going to be 9.6 times sine of 128.6 by multiplying that over all over 8.2. Now, this is where things really, we need to be careful, okay? To point out a few things real quick, there's 180 degrees in a triangle, so all of your angles existing on the unit circle will be in quadrants 1 or 2, which means in quadrant 1 or 2, sine is always going to be positive. So sine is positive here, that's positive, that's positive. So in reality, the question is, sine is positive where? So sine is positive where? Well, sine's positive in quadrants 1 and 2. So the alpha that we're trying to find could be either this guy, which I'll call alpha 1, or this guy, which I'll call alpha 2. So there's two possible options here. And so we'll just move forward, as always, and see where it takes us. Okay, so if I go ahead now and I inverse sine this, we know that we're going to get the angle in quadrant 1 because of the inverse trig function restrictions. We find out that alpha 1 is going to be 66.2 degrees. If that's alpha 1, then alpha 2 would be found by taking 180 minus 66.2 degrees, which gives us 113.8 degrees. So now it's decision time. So what we'll want to look at now is the individual angle here, alpha 1. If I take this to be my alpha, and I look back to the original, notice how 128.6 plus 66.2 is going to exceed the allowable 180 degrees in a triangle. That means then that this angle will not work. Similarly, if I take 113.8 and I add it to 128.6, that exceeds the allowable 180 degrees in a triangle. So also this guy is not going to work. So therefore, the conclusion from this problem is that under these conditions, there are no triangles possible. So that's all that you would have to say on this. There are no triangles possible, and you're finished with this problem, ready to move on to the next. All right, so this problem's similar. We're going to be given beta, A, and B. And again, just like the last one, you don't have any options here. The only option you have is to proceed with the law of sines. In particular, sine beta over B equals sine alpha over A. So I'll go ahead and get that written out. Sine of beta over B equals sine of alpha over A. And this says that sine of alpha then would be 40.7 times sine of 28.6 all over 52.5. And again, this will be the same always because of the angles allowed in the triangle, and in the quadrants they fall in on the unit circle. Sine is positive. Sine's going to be positive in quadrants 1 and 2 always. So potentially the angles that we're searching for here would be an alpha 1 there and an alpha 2 there. So punching in the inverse sine of what you see, again, I'm going to inverse sine this thing right here. When I punch this in a calculator, I find out that alpha 1 is going to be 21.8, and alpha 2 then would be 180 minus the 21.8 degrees, which equals 158.2 degrees. Now, back to an earlier conversation. We have to make sure that when we take these individual angles and we add them to beta, it doesn't take us outside the allowable 180 degrees in a triangle. And in this particular case, the 158.2 would not work, but the 21.8 would. So now we're able to move forward knowing there's only going to be one triangle possible given these conditions. So we now have our alpha, beta, A, and B were given, which means that we still now need to find gamma and C. Gamma is pretty easy. Once you have two of the angles, just go ahead and take 180 minus the given beta minus the found alpha. And in this case, that's going to give us a 129.6 degrees. And then for C, we are going to have to use the law of sines again. And like I told you in an earlier example, I'm a big believer in using given information in case some of the found information was incorrect. So we'll go ahead now and we'll say sine of 28.6 degrees over 52.5 is equal to sine of gamma 129.6 over C. So running that calculation, similar to the other problems, you'll find out that C equals the 84.5 in this problem. So we have our alpha, beta, gamma, A, B, and C now, all in this one triangle that we found. All right, so in this next example, given alpha, A, and B, again, just like the others, you don't have any options. You're going to have to go sine alpha over A equals sine beta over B in the hopes of solving for beta. So sine of alpha over A equals sine of beta over B. Therefore, sine of beta is going to be 10.6 times sine of 41.2 degrees over 8.1. Sine is always positive in this scenario. So now we're over here left determining which of these angles, beta 1 or beta 2, possibly both, possibly neither, are going to work. So inverse sining this guy right here, that's going to give us a beta 1 of 59.5 degrees, and beta 2 would be the 180 minus the beta 1 would be 120.5 degrees. So now it's decision time. We've seen cases where no triangle works. We've seen a case where a single triangle was possible. Now when we look carefully at this one, 59.5 plus 41.2 works, as well as 120.5 plus 41.2. That again keeps us under the allowable 180 degrees. So it looks like we have two possible triangles now, provided the given conditions. So at this point, what I'd like you to do is just to get organized, okay? To get organized, what I mean is I'm going to come over here to the side and I'm going to say, all right, I've got two triangles. So for triangle 1, I'm going to need an alpha, a beta, a gamma. I'll need an A, a B, and a C. And for triangle 2, I'll need an alpha, a beta, a gamma, an A, a B, and a C also. Now, the given information from here has to be in both. So our alpha 1 would be 41.2 degrees on both of these. A would be 8.1 on both. B would be a 10.6 on both. And then we found from just a moment ago our beta 1 and beta 2. So beta 1 would be 59.5 and beta 2 would be 120.5. So it leads us to now just complete the two independent triangles the same way as we would have before. Gammas are pretty easy. To find gamma 1, we'll take 180 degrees minus the given alpha minus the found beta sub 1. So in doing that now, gamma sub 1 would be a 79.3. And similarly, gamma sub 2 would be 180 degrees minus the given alpha minus the found beta sub 2, which tells us now that gamma sub 2 would be 18.3 degrees. And then for the C's, you'll have two different law of sines. I'll go ahead and I'll put this one over here, so try to keep this organized. I'm going to use sine of alpha over A equals sine of gamma over C. And for this one, and maybe I'll put the subscripts in there to be clear, sine of alpha 1, A1, gamma 1, C1. And for this one here, I'll have to do sine of alpha 2 over A2 equals sine of gamma 2 over C2. So another two iterations of the law of sines. And this is, again, just a calculator problem at this point. I feel like we've exhausted the process here. And so I'll just go ahead and throw up on the screen that C1 should come out to be 12.1 and C2 should be 3.9. So there's two separate triangles here. Given the information, all of the parts are defined. And so I think we've completed our task on this one.